Hello and welcome to the Toshogu Podcast, where we break down the latest news, breakthroughs, and ideas shaping the future of artificial intelligence. Today, we are exploring the rapid maturation of the AI stack. We are starting from the massive physical land grabs for power grids, moving all the way up to how specialized enterprise agents are being governed, and finally, how personalized safety guardrails are changing the way everyday consumers interact with AI. Let's begin. So before we can even talk about, neural networks or software or intelligent agents, we really have to talk about something incredibly grounded.
Right, the physical stuff.
Yeah, exactly. Concrete, steel, and electricity.
Yeah.
Because the reality of AI right now is heavily physical.
It really is. I mean, we spent the last few years thinking of these frontier AI companies purely as like software labs,
That's
right?
guys sitting around writing code.
Exactly.
Yeah.
Places where brilliant researchers sit in, expensive Herman Miller chairs and tweak algorithms. But you cannot scale a massive frontier model on pure intellect. You have to have the physical infrastructure to actually run the math. And right now, the most valuable commodity in the tech world isn't a new line of code. It's electricity.
It is electricity.
Yeah.
And we are seeing a monumental shift in how the biggest players are operating to secure that power. So, for example, OpenAI just secured a mind-boggling 8 gigawatts of IT capacity at the PORTS-Pike Technology Campus in Ohio.
8 gigawatts, that's just a staggering number.
It is. And they're working with SB Energy, the U.S. Department of Energy, and NVIDIA on this. They are expecting 800 megawatts to be ready by 2028 with a full build-out running through, I think, 2032.
Yeah, that timeline makes sense for something this massive.
I really want to anchor that number for you, the listener, because 8 gigawatts sounds like a fake sci-fi measurement, honestly.
It sounds like Back to the Future.
Exactly.
Yeah.
But 8 gigawatts is roughly the power output of several large nuclear reactors combined, just for one single campus.
Right, which perfectly illustrates how the fundamental business model of AI is shifting. When you're negotiating directly with the Department of Energy for that kind of grid access, you are no longer just a scrappy tech startup.
Definitely not.
You're an industrial powerhouse. And it isn't just OpenAI doing this. Look at what NVIDIA is doing right now.
Right. The chip makers, we all know them for selling the GPUs that basically power this whole revolution.
Exactly, but they've explicitly stated that chips are no longer the only scarce resource, so they are aggressively moving into securing what they call LPS.
LPS. Yeah, I saw that acronym and immediately thought, okay, what new technical jargon do I have to learn today? But it stands for land, power, and shell.
Land, power, and shell. So NVIDIA is basically acting as a real estate and utility broker for its massive customers now.
Wow.
They aren't just selling you the computer chip anymore. They are securing the physical land. They're negotiating the massive power contracts required to turn those chips on.
So they're handling the electricity, too.
Exactly. And they are building the shell, which is basically the specialized physical fortress. It has the massive cooling infrastructure, the reinforced concrete, the fiber optic trenches, everything required to house a modern supercomputer.
This feels incredibly historical to me. Like, it really reminds me of the early railroad barons in the 19th century.
Oh, that's a great comparison.
Because back then, the companies that ended up winning the era weren't necessarily the ones that designed the most luxurious passenger train cars,
Right. It wasn't about the train itself.
The winners were the ones who ruthlessly and aggressively bought up the steel mills, the coal mines, and the actual physical land that the tracks were built on. The infrastructure won the war.
Spot on.
So I have to ask you, if the game is now about multi-year industrial power contracts, gigawatt energy agreements, and concrete shells, does this mean the era of a small, scrappy AI lab competing purely on scaling their training is effectively over?
Not completely over, but the battlefield has absolutely shifted. A scrappy lab can still innovate on architecture, right? But they can no longer play the brute force scaling game.
Because they just can't get the electricity.
Exactly. If you're a brilliant startup with a few $1 million in venture capital, you simply cannot compete with a company locking down nuclear-level power agreements. The capital barrier to entry for training a true, from-scratch frontier model has become astronomical.
It's just out of reach.
Yeah, but here is why this matters to the rest of the stack. This physical bottleneck, the fact that compute is so heavily constrained and power is so incredibly expensive, that is exactly what is driving the strategic value of model efficiency.
Because power is scarce, so we have to be smarter.
Precisely. The industry is being forced to find smarter ways to operate. You simply cannot afford to use a massive, energy-hungry frontier model for every single digital task.
Which makes perfect sense. I mean, if it takes a nuclear reactor to power the grid, running every single digital task like summarizing a meeting or formatting a spreadsheet on a giant frontier model is a catastrophic waste of resources.
It's like taking a private jet to go to the grocery store.
Yes. So if physical power is forcing us to be efficient, how is the market actually adapting to this in practice?
Well, the market is adapting by specializing. We're moving away from relying on one giant monolithic brain to do everything. A perfect example of this is AWS making NVIDIA's Nematron 3.5 Lightning model available through their SageMaker Jumpstart platform.
Okay, Nematron 3.5 Lightning.
Yeah, this model is built specifically for efficiency.
I was actually looking at the architecture of Nematron, and it is fascinating. The specs say it has 30 billion total parameters, but only 3 billion are active per forward pass. Plus, it boasts a 1 million token context window. Now, before we go any further, let's translate that for you guys listening. For those of us who don't have PhDs in computer science, what exactly is a forward pass, and why does it matter that only a fraction of those parameters are active?
It's a great question. Think of a forward pass as a single cycle of the AI thinking. When you ask the model a question, it takes your text and passes it forward through its vast network of parameters to generate the next word.
Okay, so it's the process of coming up with the answer.
Exactly. And what Nematron does is called sparse activation. Instead of lighting up all 30 billion parameters, which would take a ton of electricity and time, it uses a routing system to only activate the 3 billion parameters relevant to your specific question.
Oh, wow. So it's leaving the rest of its brain turned off.
Essentially, yes. It's only using 10% of its brain power for any given thought, which makes it incredibly fast and incredibly cheap to run.
That is brilliant. And what about that 1 million token context window? What does that mean in real terms?
So the context window is basically the AI's short-term memory. It's how much information it can hold in its head at one time while answering your prompt. 1 million tokens is roughly the equivalent of handing the AI 10 thick standard novels and having it instantly comprehend all of them at once to complete a task.
10 novels all at once.
Yeah.
That's wild. So if we put those performance metrics together, AWS is claiming this delivers up to 4 times higher throughput and 30% faster task completion for high-volume agentic workloads.
Yeah, the efficiency gains are massive.
I look at this entire setup kind of like a corporate org chart. You wouldn't pay your brilliant, highly expensive CEO, let's call the CEO the massive frontier model, to spend all day sitting in the mailroom sorting expense reports, right?
No, of course not.
Or routing internal memos or checking dates on contracts. It would completely bankrupt your company. Instead, you route that repetitive, high-volume execution to highly capable, specialized middle managers.
I like that analogy.
Yeah, and those middle managers are these smaller, highly efficient, open models like Nematron. You save the CEO's expensive time and energy for the truly difficult reasoning, the long-term planning, and the complex edge cases.
That is exactly right, and that system of models architecture fundamentally changes the economics of AI. Specifically, it completely changes the profit margins for SaaS software as a service companies.
How so?
Think about the reality of deploying AI agents in a massive business environment. The vast majority of the calls those agents make on a daily basis are not deep philosophical reasoning tasks.
Right, they aren't writing poetry.
No, they're very simple, high-volume actions. An agent is, extracting a date from a PDF, classifying an angry customer email, routing an IT ticket to the right department, or checking a time-off request against a known company policy.
Just repetitive, busy work.
Exactly. And if you use a massive frontier model for millions of those simple tasks, your profit margins instantly disappear into server costs and electricity bills.
Right back to the electricity problem.
Yes. These smaller, specialized models are becoming the true workhorses of the future economy. They execute the high-volume repetitive layer so the frontier models can focus on the cognitive planning layer.
Okay, so let's say a business adopts this brilliant new corporate org chart. We have our frontier model CEO making the big plans and a literal army of specialized middle manager models executing thousands of routine tasks every single second.
Yep.
How do real companies actually keep all of this from descending into absolute chaos? Because if we aren't using the smartest, most capable models for everything, aren't we risking a scenario where these smaller agents just make massive mistakes?
That is the exact friction point the enterprise world is trying to solve right now.
Yeah.
The answer lies in how these agents are governed. Anthropic recently published a fascinating case study about a company called ABC Legal.
ABC Legal, right?
Yeah, they're a 1,100-person legal services company. They currently have over 50 production agents running, and about 310 employees interact with those agents daily.
Wow, that's a huge rollout.
It is, and they have seen up to a 50% cost reduction in the human tasks covered by these agents.
Which is an incredible business win. But here is the detail that absolutely stopped me in my tracks when I saw this.
The team size.
Yes, ABC Legal used a 15-person cross-functional team with absolutely no software developers to build and deploy those working agents in a single week.
It sounds impossible.
Look, as someone who actively struggles to get my wireless printer to connect to my Wi-Fi network, the idea of 15 non-developers deploying 50 autonomous AIs into a law firm in 7 days sounds like science fiction.
I know, it really does.
So I have to push back here. Isn't that a massive compliance risk just waiting to happen? Deploying AI into a highly regulated industry without a team of engineers sounds terrifying.
It would be a catastrophic liability if they were just turning these agents loose, absolutely. But that is exactly why this case study is so important.
Why is that?
It highlights the critical difference between the demo phase of AI, where you're just playing around with the chatbot and crossing your fingers, and real, mature enterprise adoption. ABC Legal didn't just unleash wild AI. They built a strict governance layer. They're treating these agents exactly like strictly governed software.
How does that actually work for people who don't write code, though?
Well, they use software engineering principles, but they apply them to natural language. For instance, they use code repositories for the agent's prompts, the tools the agents are allowed to use, and their system credentials.
So it's very organized.
Very. They use what developers call pull requests and maintain a strict version history.
So for you listening who might not be a developer, a version history and a pull request is essentially like a highly tracked Google Doc.
Exactly.
If someone wants to change the instructions given to an agent, they have to officially propose the change. It is reviewed, and if the new instructions cause the AI to hallucinate or make a mistake, they have a rollback capability.
Yes, the rollback is key.
They can literally just hit undo and revert the agent back to the exact state it was in yesterday while maintaining a detailed audit trail of who made the change.
Precisely. You don't need to know how to write Python to propose a better English instruction for an AI, but you do need a system to track that change.
Right.
And crucially, ABC Legal implemented a very strict human feedback loop to manage this. They created specific roles.
Oh, like what?
So they have a harvester whose job is simply to collect the work the agents have done and look for areas of improvement. Then they have a tuner who proposes changes to the agent's configuration or its prompt to fix the issue.
Okay, so a human is always checking the work.
Yes. And finally, a human manager must explicitly approve that change before it ever goes live. This governance, the versioning, the observability, the human-in-the-loop approval process is the critical middle layer.
That makes total sense.
It's what turns a wild, unpredictable AI experiment into a manageable, highly reliable software asset that a law firm can actually trust. So the agent itself becomes something you can audit, measure, and control, just like a traditional database.
Exactly.
But here's the problem. This strict control layer works inside a single, well-managed enterprise where everyone plays by the rules. What happens when these autonomous agents start interacting across the open internet and bad actors start using this exact same highly efficient automation to bypass our enterprise guardrails?
That's the scary part.
Right. Because if a legal firm can deploy 50 agents in a week to do good work, a hacker can deploy 50,000 agents in a week to do malicious work.
And that raises an incredibly urgent question about the speed of modern cybersecurity. Greg Brockman from OpenAI recently outlined a concept called the defender's window.
The defender's window.
Yes. His core argument is that AI models are increasingly capable of automating the tedious, complex parts of real-world cyber attacks. We aren't just talking about a model writing a convincing phishing email anymore.
We're way past that.
Way past. We are talking about autonomous agents that can actively chain multiple weaknesses together across different pieces of infrastructure.
Like what happened with the recent incident involving OpenAI and Hugging Face.
Exactly. In that incident, we saw how an agentic system can poke at an API, find a small vulnerability, leverage that tiny crack to uncover a hidden credential, and then use that credential to pivot laterally through a network.
All automatically.
All automatically. And it can do all of this in seconds.
Seconds. Wow. I picture this as a digital immune system problem. For decades, Our cybersecurity is basically reliant on human white blood cells,
Yeah.
right?
Yeah, human analysts.
A threat comes in, a human analyst gets an alert on a dashboard, they spend 20 minutes looking at the server logs, they figure out what the virus is doing, and they write a patch or block an IP address.
Which is incredibly slow.
It is. But if the digital viruses we face are suddenly mutating, learning, and chaining attacks together at machine speed, our human white blood cells are just hopelessly slow. Our defenses have to operate at machine speed, too. We need an immune system that doesn't just react to a virus, but actively predicts the mutation and locks the doors ahead of it.
That is a perfect way to look at it. You simply cannot have a human speed defense against a machine speed attack.
You lose every time.
Every time. For AI native companies, security can no longer be a launch later feature or an afterthought. It is a fundamental day one operating requirement. Security teams are being forced into a literal arms race where they must fight automation with automation.
Wow.
OpenAI themselves are a prime example of this defensive posture. They aren't relying entirely on human analysts anymore.
They're using their own AI.
Exactly. They're using their own AI internally to automatically validate code changes before they are deployed, to actively hunt for vulnerabilities in their own systems, 247, and to rapidly triage security alerts.
That's fascinating.
The AI handles the overwhelming volume and speed of the data while leaving the human security engineers responsible for only the highest impact final decisions.
It's a complete paradigm shift. We're moving from human analysts staring at dashboards to a world where our AI agents are actively wrestling with malicious AI agents in the background of our networks, constantly patching holes before we even know they exist.
It's invisible warfare.
Yeah, but this brings up a really interesting parallel. Just as we are realizing that a universal one-size-fits-all approach is failing for enterprise security, AI platforms are realizing that a universal one-size-fits-all approach is failing for individual consumers as well.
Absolutely.
The industry is rapidly beginning to segment trust, risk profiles, and how AI actually integrates into our specific cultures.
This is perhaps the most visible shift in product architecture we're seeing today. For a long time, the holy grail was to build the single, omniscient, universal assistant.
The one AI to rule them all.
Exactly. The idea was that one giant model would behave the exact same way for everyone, whether you're a CEO, a student, or a retired grandparent. But that universal model is fracturing.
It really is, and we are seeing it in real time. Look at what OpenAI just rolled out. ChatGPT for teens.
Yeah, that's a huge deal.
They are automatically placing users between the ages of 13 and 17 into a completely dedicated, customized experience. It has stronger default safety guardrails and robust parental controls. But what I found fascinating is that it includes a dedicated study mode with responsible homework interventions.
Which is so clever.
Right, because if a teenager asks the AI, hey, just write my history essay for me, the AI is explicitly instructed to push back. It won't do it. Instead, it guides them through the learning process, asks them Socratic questions, and even gives them reminders to take screen breaks.
Which highlights exactly why user identity and context are now core inputs for product architecture. Think about the liability and the user experience differences there.
Yeah, it's massive.
A 14-year-old doing history homework has a fundamentally different risk profile and requires a fundamentally different behavioral model than a 45-year-old data scientist analyzing financial spreadsheets.
You can't treat them the same.
You can't. The AI needs to be able to adapt its level of autonomy, its tone, and its boundaries based entirely on who is sitting at the keyboard.
And it isn't just about age segmentation or safety either. We are seeing cultural segmentation too. Google just announced long-term partnerships between Gemini and major global soccer clubs, Arsenal, Bayern Munich, Liverpool, and Paris Saint-Germain.
Yeah, the sports angle is fascinating.
They are explicitly positioning Gemini as the official consumer AI partner for these teams. So I have to ask you, are we officially watching the death of the universal AI assistant?
I think we are.
It seems like instead of one sterile AI for everyone, the big companies are trying to weave hyper-customized AIs into our specific daily identities, whether that identity is being a high school student trying to survive pre-calculus or a diehard soccer fan constantly checking team stats.
I believe we're witnessing exactly that. The universal assistant was a great proof of concept, right? But it lacks stickiness.
Stickiness.
Yeah, competition at the application layer isn't just about technical benchmark scores anymore. Nobody outside of an engineering lab truly cares if a new model scores 2 points higher on an abstract logic test.
Right. Everyday people don't care about benchmarks.
Exactly. What everyday users care about is how the technology fits seamlessly into their actual lives. It is about cultural partnerships and habitual use. If Google can make Gemini the default trusted lens through which a massive global fan base interacts with their favorite soccer team, getting real-time stats, tactical breakdowns, or personalized content, that creates a much deeper, more resilient user habit than simply having a slightly smarter algorithm.
You are tying the AI directly to their passion.
Precisely.
So we have traveled from the absolute bottom of the stack to the very top today. We've gone from massive gigawatts of physical power locked down in Ohio to highly efficient, specialized middle manager models saving sauce margins.
It's a huge spectrum.
It really is. We've seen how law firms are strictly governing fleets of autonomous agents, how cybersecurity is shifting to machine-speed warfare, and finally, how AI assistants are being hyper-customized for teenagers and soccer fans.
A lot of ground covered.
And seeing this entire ecosystem laid out leaves me with one final, very provocative thought for you to consider. If AI models become our physical infrastructure, our machine-speed security guards, and our hyper-customized, personalized companions, what happens to our shared objective reality?
Ooh, that's a heavy question.
Right. When every single user has an AI operating with entirely different behavioral rules, entirely different cultural contexts, and entirely different risk profiles, do we lose the common cultural ground we currently share? If my AI filters and explains the world fundamentally differently than your AI, based on our distinct identities, how do we ever agree on what is real? It's something deeply important to think about as we continue to build and integrate this new ecosystem into our daily lives. That's all for today's episode of the Toshogu Podcast. If you enjoyed it, like this episode, subscribe, and join us next time for the latest in AI. Until then, keep building what outlives you.